So I'm going to tell you about the second of our 4 labs, the Streaming and Open Data Lab. And so this story, we're actually going to start this story talking about shipping. So when I talk about shipping, I'm actually talking about what, if you turn around and look across the road to the waterfront, this is San Francisco's Embarcadero, and it's kind of a very old historic shipping center, although you see that there's not a lot of shipping that happens there today. So this is a story about that kind of shipping. So if you go back to before the 60s, this is what shipping looked like. And it's called break bulk cargo. And basically what happened, the way it worked is that whatever cargo was being shipped, whether it's like coffee beans or pork or manufactured objects, electronics, they would all be packaged by the manufacturer or by the farmer or co-op into whatever kind of packaging they wanted, and then it would be loaded kind of piece by piece, bag by bag into the hulls of ships. So it was a very labor-intensive process, and it looked like this. So it was lots of people, and it was like this giant Tetris game of fitting each piece into the hull of a ship. And if you were around here in the 40s and 50s, there would just be this kind of maze of activity along the Embarcadero, which is the dock workers loading and unloading all of this cargo. And then something pretty big happened in the late 50s that completely changed this picture, both on a global scale, but you can also see the local artifacts of that, which is there's no more shipping happening along the San Francisco coast. It's all moved to Oakland. And the thing that changed all that is containers. So containerization, which is this standardized box, essentially, where all of the cargo to be shipped, instead of being put directly onto the ship, instead was put into a box, and then that box was put onto the ship. And it completely changed the kind of global landscape and the global business landscape of how we move cargo from one place to another. And it was really all just about standardization. And so you can ask, so this is a picture from the Economist, and you can ask sort of what was the global economic impact of this. And from the late 60s, when this started to take hold, until today, there was a 7x growth in world trade. And there's a lot of factors that play into that, but there's some recent work from this paper here that actually attributes a lot of it to the efficiencies that came from containerization. And we can dig into this a little bit more and ask, so what was, boxes kind of make sense, there's this intuitive sense of standardization, but we can actually ask really what was the impact, like how did this actually change global shipping? Because it wasn't just that, that the price of shipping went down. That actually didn't change that much. The impact were these other 4 things, these secondary effects. So first of all, 20 times faster loading and unloading at port, that's just a huge, huge difference. The average journey time was cut in half. Importantly, the length of time was much more consistent, and that kind of makes sense because you don't have the variables of what you're unpacking that's kind of creating a high degree of variability in how long the journey takes. You're kind of always just unloading the containers themselves, and that really depends just on the size of the ship and maybe on the port. It doesn't depend so much on what the actual cargo is. And then finally, having these standardized boxes unlocked the ability to do pretty easy intermodal journeys where you would have, now you have a large ship that will pull into the Port of Oakland, and then containers will be offloaded directly to trucks, and then those trucks could go around the block to a warehouse, or they could just start their journey 200 miles inland to supply something further away. So there's this really easy movement of goods from from a ship to a truck, or from a ship to a rail car. And so to kind of summarize this, this really simple, now seemingly obvious invention, which is a box, enabled really efficient supply chains and ultimately entirely new markets. So this, this had all of these direct impacts on shipping, but it indirectly unlocked kind of everything we take for granted about the supply chains we have today, especially around electronics and and sort of high-tech goods that a lot of which are designed here but manufactured elsewhere, and then easily and cheaply shipped here. So it had this huge sort of tertiary effect of changing markets and marketplaces and supply chains and how we design and build things. So the kind of weird thing, let's start talking about data, which is what this interest group is about. The kind of weird thing is that you would think that data is about computers and that would be really high tech, and it is, but in a weird way, data is actually behind how we treat shipping. So let's talk for a second about data and storage. So if we think for a moment of the phone in your pocket as kind of a example, or like a sort of gold star example of a sensor. So the camera on your phone is a form of sensor, right? Let's think of it that way. And we ask, how much does it cost to store a reading off of that sensor, which is a photo? In 1980, it was about $2,000, which is kind of crazy, right? Like it was just literally like, you didn't have digital photos for really anything. That's ignoring the cost of CCDs and the actual electronics to do it. So $2,000 to store a photo. Huge change by 1990, that's $40. 2000, it's 5 cents. And then, this is a few years old, the data that I got for this, but by 2010, it's so cheap that if you're rounding to the nearest cent, it's basically free. So in a way, the cost to store data is just, it's rapidly approaching zero for many applications. And a byproduct of that is just the amount of data in what the analysts call the digital universe is just growing explosively. So this is basically trying to account for all data that we have for everything. Everything from personal photos to news stories to personal data like in Facebook. Everything is in the digital universe. And if you look at this, you can see that around 2013, so this dotted line is here because in 2013 the digital universe was like 4 billion petabytes, and then by 2015 that's already doubled to 8 billion petabytes. So this is very much an exponential process. And so you would think like, okay, we have tons of data, like this should be benefiting everyone in lots of ways. And then the interesting thing though is that it seems to be very much like underutilized. Like we have all this data, we can think of it as a resource or a raw material, but we're really still not putting it to as much use as we really could or should be. And here, like, I'm talking about the digital universe and all data. The imagery here is, a lot of what in this lab we're thinking about is more around industrial data or more around think less personal data, although that could be part of it, but think less of personal data and sort of data where there's sort of big privacy implications, and more around industrial data where there's a great case study from a McKinsey report where, and if any folks were here last summer, you might have heard this before, but they did a study of an oil rig, and oil rigs are in a way kind of a peek at the IoT sensor future because they're highly instrumented, or in some cases they're highly instrumented pieces of hardware. And so this oil rig has like 30,000 different sensors kind of constantly generating data, but of those potential 30,000 data points every unit time, only 1% is actually being used. And there's a lot of reasons for this. So this is like a strange and pretty, I think, extreme underutilization of a resource that's available. And there's a lot of reasons for that, but one of the big reasons is that it's just too hard to share data between organizations. So company that owns this, the company that runs this, it's very siloed. There's lots of data that they generate that's useful to that company, but there's also tons of data that could be useful to other companies, other individuals for their own applications. And so data, it's actually in a weird way, it's more like how we treated cargo 50 plus years ago, where it's so expensive to sort of put into your own ship that there's not really, it's just too expensive, and there's not enough incentive to share that data or to share it with another organization. It's very sort of primitive in how we sort of package the data, so to speak. And so to put the kind of need or usefulness of sharing data into a little bit more of a context, so let's think about the kind of data that might be generated by sensors. So this is now becoming a story a little bit about IoT, Internet of Things. So imagine a smart city of the future where you have sensors that are kind of deployed near future too. It's not very far away. But you have sensors deployed into different parts of the landscape. So you might have cameras that are looking at the street and they can see if there's potholes or if there's flooding in the street. You might have pollution sensors at intersections that can determine nitrogen levels and ozone levels and other sort of vehicle emitted pollutants. All of these sensors have they have a stream of data that's coming off of them. And as you start to imagine this being deployed at scale, it's not, in my mind at least, it's not going to make sense for any single organization to own all of these sensors. So a great case study for that is, so Philips, which is a big light bulb manufacturer, they own a sort of valuable piece of real estate in the city, which is the lamps, the street lamps throughout the city, and so they're working on, basically adding sensing capabilities to their light bulbs, and so that's a data stream that they now own. But that's just a fragment of the total sort of set of data that you might collect in a city. And so to make really the most use of that, to say, okay, we have all of this data, let's collect it all, and then let's do something useful with it. Let's change the timing of the lights so that we can minimize pollution while also having pedestrians be able to cross in an efficient way. That's going to take streams of data from multiple different sources. And so if we don't have a way to basically package the data, move it somewhere else, and maybe receive a little bit of revenue for sharing that data, we're not going to be able to build out those use cases. So I kind of said this a little bit before, but sharing and trading data is clearly valuable, but in a kind of strange twist of the history of technology, we're still moving it like break bulk cargo. We don't have easy ways to give an outside party, whether that's a city or an individual, access to some piece of data deep inside of our database. We have things like APIs which are starting to get at that, but they just aren't easy or simple enough or accessible enough to really unlock the full potential of this. And so that's really kind of the mission of the Streaming and Open Data Lab, which is to explore data as a raw material and to really try to figure out how we establish and use more of a global supply chain of this data. So it's about getting the most out of this data by sharing it and compensating people for sharing it. So creating technology and incentives and the tools and experiences around that sharing. So there's a few kind of specific aims within the lab. So the first one is around IoT and data origination, and this is actually very much along the lines of the question we had during Dan's talk, which is how can trusted data be generated by internet-connected devices that might be deployed, at someone's house or in a solar field or in an otherwise kind of untrusted environment. And the reason that's important, and so Dan already mentioned this, but I'll mention it again. This is the solar renewable energy certificate project that we did about a year ago. And the reason this is important is because we built a solar panel that in an automated way measures how much power it's generating, and it reports that data. And the actual data itself, which is how much energy was generated over a minute or an hour, that's sort of fundamental to what this device does. But you can ask, how is the data packaged? How is the metadata around that packaged? And depending on what your answer is, there's different things you can do with that data. It really changes how valuable it is. So if you don't secure the data, if you don't have a way to know if it's been tampered with, and if you don't have a way to trust the device, then the data is just kind of useful logging. You can look across a solar field and say, yeah, this panel is generating a lot, this one's not generating a lot, maybe we should go fix that one. And that's still useful. But if you build kind of a secure package around the data, and you build the infrastructure that lets you trust the device at the device level, and you build the infrastructure that you can look at a portfolio of devices and spot ones that might be cheaters, if you have that level of confidence in the data, then you can treat it literally as a financial asset, which is what we did. So the data coming off of this panel was a renewable energy certificate. So it was a financial thing that without any sort of human inspection or intervention went into NASDAQ's Link marketplace and could be further sold as a renewable energy certificate. So how we treat data and the kind of boxes we build around the data is really, it's really important for how much use we can get out of it. So the second big sort of aim of this is sharing in new markets. So this is about what new infrastructure and technology needs to exist to facilitate better sharing of data. So if we can get data off of internet-connected devices and we can trust it, now how do we share it from the organizations that have created it or own the devices to other organizations who might want it, both from a just building applications and products point of view, but also from a revenue point of view. If you can share data and be compensated for it in real time and easily, then that sort of changes the incentives of sharing the data a lot from how they are today. And so a couple of projects that are kind of related to that. One of them is Nomad, which is a decentralized streaming data system or platform. And it's a way basically for any party or any organization to real-time stream data to another party without relying on any centralized servers or any centralized companies. I won't go into it in a lot of detail, but it's something we've been working on for the past year, and it could be a useful tool for some of the explore, although more likely build sprints that you guys do this summer. So if you have questions about that, come talk to Gavin or me. And then Jules was a project that we did. It was actually in the Corporate Explorer version of what you guys are doing today, or these 2 weeks. This was from back in March, and it was looking at how by having more sort of open data about what's happening in a power grid, you could actually use electric vehicles and the batteries that they have as a way to kind of pull and push electricity onto or off of the grid where it's needed. So if you think of, electric vehicles are basically this mobile battery, and you want to have some charge for the person who owns the car, but in a future where you have self-driving vehicles, you can now think of the vehicle as a roving battery that has a few different potential purposes. It could be moving a person, but maybe when it's not moving someone, maybe it's actually moving electricity in a way from one part of the grid to another part of the grid. The third main area is interfaces, visualization, and media. And this is really just how do you visualize and interact with data, especially when it can start coming from any source. So you have some data from one type of sensor, a street level pollution sensor, and then you have camera data. Are there new tools that we should be building to support human decision making about that data, and then capture, if you have an insight or like a way to analyze that data, can we capture that analysis kind of like a spreadsheet, but then push it off into a decentralized cloud and have it sort of automate that analytics without you having to touch that anymore. And so we built a kind of prototype of what that might be like, which we were calling living spreadsheets, which uses Nomad, which is this, the data, decentralized data streaming platform that I just talked about, to pipe data from multiple totally separate sources into a spreadsheet, and you could actually use really simple addresses to fill out rows and columns of a spreadsheet. And then once you get this disparate data into your spreadsheet, you can do all of the nice spreadsheet functions that you can do on any data, including sorting it. And in this case, we set up a 2D scatter plot to see how much. So it was comparing how much solar energy is available. So this is how sunny is a location, versus how much does electricity cost. So at the places where there's a high cost of electricity, but it's also very sunny, these are going to be places where you might want to buy solar. These were completely different data sources that we pulled from different places and piped them in using Nomad, and it was real time. So anytime this data changed at their origination, the spreadsheet would have the most up-to-date values. And Joe will be happy that Oakland is up there in the top right quadrant, so Oakland is the place you should buy solar. So to kind of summarize this, so this is the Streaming and Open Data Lab. It's really about treating data as a raw material, but one that's valuable in its own right. But the more we kind of refine it, the more we do something with it, the more value we can get out of it. And a big part of that is sharing the data, streaming the data, especially in real time, moving data from one place to another in real time so that applications can use it and make decisions based on it. It's about IoT and data origination. So that's the solar panel. It's about how we actually share from an infrastructure perspective, but also what new markets and what new products can we create once we assume that sharing is easier. And then finally, it's about interfaces, visualization, media. So how do we understand this data better, and how do we use it to change decisions that we make? Okay, so one more story about containers, because I really want to leave you with the impression that the packaging does matter. So does anyone know what this is? Yeah. So it's a microsatellite. And when I first learned about microsatellites, I learned it in the context of Planet Labs, which is this startup actually down the street that's kind of covering the Earth in satellites that they're a little bit bigger than this, to do basically imaging of the Earth. Their goal is to get to imaging of the Earth every single day. So you can really start to think of surface imaging as a longitudinal thing and not a single point in time. But the part of the story that I didn't initially know that's actually, I would say, maybe even more exciting than what Planet Labs is doing is that, so this is called a CubeSat, and it's a standard for satellites. So there's a standard 10 centimeter by 10 centimeter by 10 centimeter form factor, and this is actually, so this was invented in the early 2000s. This is what unlocked what Planet Labs can do, and the reason for that is because it's created this low-cost market for building and launching satellites. So what Planet Labs does is they actually manufacture these things in Soma, like less than a mile from here. They manufacture in-house, and then they just buy space buy space on different rockets that are going up to space, and it's kind of a standardized thing. So they'll say we need 3x this space to send up in a rocket, and it's much more of a kind of commodity type of market than the bigger satellites. And it's just completely changed the way that they design, engineer, and launch these things, because there's so much more volume going up into space. They can be more experimental, so they tend to put more consumer-level electronics into these things, which gives you much more functionality than you would with typical spacecraft, which are kind of lagging. They're actually lagging technology because there's such a low tolerance for risk, and no one wants to kind of mess with what has worked. And it's just completely, it's this little box, this standard that has just completely changed how this industry works.